Hello everybody, Mrs. Bowen here. Last week we worked on factoring out the greatest common factor, also known as the GCF, when we were working with polynomials. And this week we're going to continue to use the GCF in order to help us with learning target 7.4. I can factor polynomials by grouping. So grouping is a type of method that we will use in order to factor. And in order to do grouping, if we want to factor it, there has to be 4 terms. So if there are not 4 terms, you may not factor by grouping. Meaning when you look at today's notes, we're just going to do the front side today. So we have 4 examples and 4 U-tries. And you'll notice that every single problem has 1, 2, 3, 4 terms. So our first step today will be to split our polynomial into 2 groups. And I'm going to abbreviate polynomial as poly. Split poly into 2 groups. More specifically, we could say we're going to have a first half and second half. That's where the grouping comes in. We'll chunk it into the first group or the first half and the second group or the second half. Once you split your polynomial, then we have to look at each half separately. So we'll first look at the first half and we have to factor out the GCF. So I'll say factor GCF, which again is greatest common factor, out of first half. And then we have to factor the GCF out of the second half. So you have to do them separately because they are chunked into different groups. I left a little bit of space here beneath step 2. So this is still a part of step 2, but I need to make a very important note. And this has to do with pulling out your greatest common factor for your second half. So the key term that you have to look at when you're trying to pull out the GCF for your second half is the third term. So we're going to make a note that if the third term is negative, we have to factor that out. If third term is negative, we're going to say pull out the negative. And this is very important. If you don't do this, you'll notice that you won't have something in common in order to factor by grouping. So please make sure you have this special note. We're looking at the third term. If the third term is negative, then for your second half, you have to pull out that negative. And then our very last step, once you've split it into 2 groups and you've pulled out the GCF for the first half and the second half, final step would be to then factor out the common polynomial factor. I'll abbreviate polynomial again as poly. So you'll see when we do this today, you will have something in common. And so you'll have what I like to say common parts and leftover parts. So we'll take a look at that. All right, so once you've got your steps written down, let's jump right into an example. So let's zoom on into example 1. The directions tell us to factor each completely. So right away I have 4 terms. I need to chunk it into the first half and the second half. So I often like to draw a line. Today I'll continue to do it in pink to show that this is me chunking it into first half and second half. Now, step 2, I just want to look at the first half. So ignore the second half of my polynomial. I'm just looking at the first and second terms, and I need to pull out the GCF, again, the greatest common factor. Or last week, we would say, what is the biggest number and the biggest variable that you could pull out? So looking at the numbers, 3 and 9, I can see the biggest number that each of those terms has to give is a 3. And then looking at x cubed and x squared, the biggest variable that each of those terms has to give is the x squared. So the biggest GCF that I can pull out is 3x squared. So for my first 2 terms, I can pull out a 3x squared, and then we have to do like we did last week. I have to say 3x squared times what gives me 3x cubed, or you can think of it as like backwards distributive property. Well, we've already got the 3 taken care of, but I still need to add another x because x cubed is x times x times x, and I only have 2 here, x times x. So I would say 3x squared times x gives me 3x cubed. I now need to do the same thing here. 3x squared times what gives me 9x squared, and that would be plus 3. All right, so I did my first half. So now you could cover up your first half and just look at the second half. So my second half, or the third and fourth term, are x plus 3. So you need to consider, is there any number or variable that I could pull out there? And in this one, there's actually not, right? The third term here doesn't have a 3 that it could give, and the last term doesn't have an x that it could give. So if there's nothing you can pull out, you can just say a 1, right? Because 1 times anything is itself. So the biggest thing that I could pull out there is a 1. And 1 times x would give me x. 1 times 3 would give me 3. So I'm done with step 2. In the first half, I pulled out the 3x squared. In the second half, all I could do was say to pull out a GCF of 1. There was nothing else in common. And now I'm hoping that you're looking at this and you're noticing something looks like it is in common, and that's what step 3 says. Factor out the common polynomial factor. I'm hoping you notice that this x plus 3 is in parentheses for both of them. So that's the common polynomial factor, x plus 3. So this is one factor, what's in common. And then the other factor is just the leftovers. By leftovers, I mean here we have a 3x squared, and here we have a 1. So that would be your final answer. You've got 2 factors. First parentheses is your first factor, second parentheses is your second factor. So you just took this polynomial and you factored it by grouping to get 2 factors. All right, let's look at example 2. Have to start example 2 the same way. You got to split it into first half and second half. So I've got my 2 halves. Just looking at the first half, I'm trying to say what is the GCF, the greatest common factor, or the biggest number and the biggest variable that I can pull out of 30a cubed and 12a squared. Let's see. I know 6 goes into 30 and 6 also goes into 12. So the greatest number is 6. And then you have to consider the variable. Both of these terms have an a squared that they could give. So my GCF there is 6a squared. And now I need to fill into my parentheses, so I have to work backwards. 6a squared times what gives me 30a cubed? Well, 6 times 5 gives me 30, and a squared times a will give me a cubed. I also have to do it for the second term. 6a squared times what gives me 12a squared? Well, 6 times 2 gives me 12, and my a squared is already taken care of. So 5a plus 2 is what I have in parentheses here. I'm hoping that when I factor by grouping for my second half, I also have 5a plus 2 in parentheses. So now we can ignore the first half, go on to our second chunk here, and I want to pull out the biggest number and variable that I can. And I can tell the number 5 goes into both 25 and 10. So my GCF there will be 5. And think of backwards distribution. 5 times what gives me 25a? That would be 5a. 5 times what gives me 10? That would be 2. And this is perfect because we're noticing what is in parentheses is common. We got the same thing there, 5a plus 2, meaning that's one of my factors. And then my other factor is the leftovers. We've got a 6a squared and a positive 5. So there'd be my final answer. If you're ever trying to factor by grouping and for some reason what's inside your parentheses here isn't the same, like let's say for my second chunk, if I didn't get 5a plus 2, that's how you would know you made a mistake. And I would say at that point, I would probably just check and see if you made a mistake with your mental math, or you could erase the whole problem and start again. Maybe you didn't pull out the right GCF, but what's in parentheses has to be the same. That's the idea with factoring by grouping. All right, example 3, chunk it into 2 parts. Notice with all of these, I'm keeping this third sign with the third term, right? A positive x, a positive 25a here, and then here this is a negative 30p. So make sure you're keeping that sign with the third term. So be careful where you're putting your line. All right, my first half. What's the biggest number I can pull out of 12 and 2? That would be 2. And what's the biggest variable I can pull out of p cubed and p squared? That would be p squared. Put my parentheses, think of my backwards distribution. So 2p squared times what gives me 12p cubed. 2 times 6 gives me 12. And p squared times p gives me p cubed. And then I have to do it for the second term. 2p squared times what gives me 2p squared? Well, just times 1, right? It already is 2p squared, so times 1. Now look at our second chunk, so ignore the first group. And right here, this is really important, this negative sign that we see. Up in our top notes, we made a note and we said, if this third term is negative, you have to pull out that negative. So whatever we're pulling out here, it's going to be negative something. So keep that in mind. This is really important. If this third term is negative, you do have to pull out the negative. So what's the biggest number I could pull out of 30 and 5? That would be 5, but we said we're going to make it a negative 5 because our third term is negative. Put your parentheses, and let's hope that when I do this backwards distribution here, I'm going to get 6p plus 1. That's what I'm hoping. Negative 5 times what gives me negative 30p? That would be 6p. Negative 5 times what gives me negative 5? That would be positive 1. So that worked. Look at what's in common. My 6p plus 1 would be my first factor. And then my second factor would be my leftovers. I've got 2p squared minus 5. So there would be my 2 factors. We took this polynomial and came up with 2 factors. All right, last example before you try some of your own. And I'm noticing this last example when I go to split it into first half and second half, that this third term is negative. So again, that's something you should be paying close attention to. When right here you split it and you have a negative, you're going to have to pull out that negative. So, I mean, right away, if you want to, you can even put a negative down because you know for your second group, you've got to pull out a negative. All right, let's do our first half first though. So what's the biggest number I can pull out here? Well, I can't really pull out a number, right? My first term doesn't have a coefficient. But as far as the biggest variable, I could pull out an x. And then I'm saying x times what gives me x squared? That would be x. X times what gives me negative 2x? That would be negative 2. In my second grouping, what's the biggest number I can pull out here? I've got negative 9 and 18. Biggest number would be 9, and we said we are going to make that negative because our third term is negative. Put your parentheses because we pulled out the GCF, and now we have to work backwards. So negative 9 times what gives me negative 9x? That would be x. Negative 9 times what gives me 18? That would be negative 2. And we can see what's in common, or our common factor is the x minus 2. And our leftovers in this case are the x and the negative 9. So we did 4 examples. Notice we did 2 examples where your third term was negative, so just be cautious of that. That does mean you have to pull out that negative. There are now 4 U-tries, so at this time, go ahead and click pause and see what you come up with for these 4 U-tries. All right, let's see how you did. So here I have the 4 answers to the U-tries. Notice that with the U-tries, I gave you the bottom 2 where your third term was negative, so you did have to factor out a negative for your second grouping. But check your answers. If it looks like you're doing well and you're getting them correct, you could try a few problems on the independent practice if you would like to get some further practice and be able to check your answers. Otherwise, feel free to jump right into the quick check for 7.4. If you got any of these U-tries incorrect and you need some more help, feel free to shoot me a Schoology message or just visit me at my Zoom office hours. I hope everybody has a great week.